Welcome everyone to the course Water and Wastewater Treatment. My name is Mansi Tripathi and here for this course. So we are entering the 11th week of the online doubt solving session, which makes this class the second last class of the session. So we'll start. I'll show you some questions. You can answer those questions and I'll show you answers too. But it will be better if you can solve with us. Okay. So I'll start the session now. I'll share my screen. So I share my screen now. Hope you will be able to see that. So as I was saying, this is the 11th week of water and wastewater treatment, 11th problem solving session. So we'll start now. So for the first question is, select the correct statements regarding chemical and physical adsorption. So in this week we are mostly talking about the tertiary water and wastewater treatment. So the question talks about the chemical and physical adsorption. So what is adsorption first? It means in which the phase of the pollutant is changed. For example, meaning in a beaker we have solid phase. These are the solids with lots of pores. Okay. So there are few pollutants which are in the water. So this pollutant will go move from here and this will attach to the surface. So how this process is called adsorption, means there is change of phase. Now we have two types of adsorption, chemical and physical. So these are the options from which you can select it. If the pore volume is taken up by the pores of different sizes, then the efficiency of adsorption is decreased. These physical adsorption is the force of attraction include only physical forces and exclude covalent bonding. And what is chemical? Here, according to this, the media generally can accumulate multiple molecular layers. And these metal oxide surface can absorb humics and metal. So here we're talking about specific type of adsorbent, which is metal oxide. So what will be the answer? I will give you a minute and we can see the answer. Okay, we'll see the solution now. So the option is B and D. Physical adsorption does not include any covalent bonding because this is a chemical bond. And D option, metal oxide surface can absorb humics and metal. Okay, so this is how it is done. Next question is, this is a numerical question. Adsorption on toluene or activated carbon obvious. Triangulic acetone equation where C is in milligram per liter and Q is in milligram per gram. So this is the Triangulic acetone equation. A solution at 25 degree because the temperature is important at the adsorption. Okay, 0.65 milligram per liter of toluene to be treated in a batch process to reduce the concentration to less than 0.025. So we want to convert 0.65 to 0.025 by adsorption. So how much activated carbon dose is required? Okay, this is a very simple question. We have to just put values in this C. Rest of things are given and you will get the Q. So please try to find out the answer of this question. Okay, we'll move towards the solution. So the solution is, we know equilibrium concentration is this much, which can be determined. So, okay, Q total is 23.4, C total 0.065, which is 19.096. How 19.096? Okay, so this is the isotherm expression from which we are getting this thing. By so we got Q. Now C total is C total plus Q into C adsorbed in activated carbon. So this much is adsorbed in activated carbon and 0.0565 we know the total. So this is what we want. This is adsorbed. So we can get the value CAC from here. This is the solution. Moving towards next question. Select the correctly matched pairs regarding cause of adsorption. Okay, so moving towards next question. The question is select the correctly matched pairs regarding causes of adsorption. We have to select the correctly matched pairs. First is dislike of water phase means the compounds which don't like water phase. Compounds which don't like water phase is called hydrophobicity. You can get from this word what does this mean. The option is van der Waals forces are surface charge interaction. Third is electrostatic forces are physical attraction and chemical are pi and hydrogen bonding. This is a very simple question. We need to know the different type of bondings and the interactions present in the water body. So you can see the solution. I'm sorry for this. So the answer is A and D. So dislike of water forces is hydrophobicity, correct, because it has phobia of hydro means water. And chemical forces are pi and hydrogen bonding. Electrostatic forces are not physical attractions. Similarly, van der Waals forces are not surface charge interaction. Okay, this is opposite actually. Next question is match the two types of adsorbent with their respective properties. Talking about physical and chemos option, we have option process speed is limited by mass transfer, specific charge exchange of electron, higher heat of adsorption, and reversible and exothermic. What can be the answer? Take some time and try to answer this question. Okay, we'll move towards the solution. So the correct option is 1A, 2C, 1D, 2B. So 1A. So of course physical adsorption is limited by the mass transfer limitation and it is reversible and exothermic. Whereas chemosorption has higher heat of adsorption and it is specific to exchange because it's chemical bond, right? So of course there will be specific exchange of electron and bonds. Okay, it won't go and sit anywhere. And thus there needs to be the formation of bond. That's why it will be very specific. Moving towards next question. Select the correct statement regarding ion exchange. So what happens in adsorption? In adsorption, a pollutant will go just sit on the site. Okay. But what happens in ion exchange? Something will go, then it will move in the pores and sit, and the other thing will come out. So when the two-way exchange is there, which this is called ion exchange. So in ion exchange, there is one extra process which is coming out of ion, coming out. Okay, and adsorption just going and sitting. So options are weak acid resins have lower pKa compared to strong acid resins. It is easier to regenerate the weak acid resins compared to strong acid resins. There is stronger attraction to singly charged ions due to smaller, higher radius. Further, in the resin column, exchange reaction begins to saturate the upper levels before the lower levels given a direction of flow is from top to bottom. So what is this saying? If the flow is coming from here, then which will start getting saturated first? This layer or this layer? Okay, this is top layer, this is bottom layer, so which will be saturated first? This is showing in D. So the answer is B and D. So this is correct. It is easier to regenerate weak acids resins compared to strong. It can be even regenerated to 90%. Okay, or more. And when the flow is passing from here to here, first this part will be saturated. Okay, then this will be active. Then this will be saturated. Then the saturation zone will go down. Okay. Next question is select the particles which are specifically removed by nanofiltration but not by filtration through higher filtration pore sizes. Talking about nanofiltration which having size very small size. So this particle can be removed by this but not by microfiltration or bigger any other bigger filtration. What can be those things? Okay. Moving towards the solution, it is divalent ions and dissolved organic matter. Okay, because this is very small. Nanofiltration is very small. So these are these can be removed by bigger particle also. These things. But this divalent ion dissolved organic matter can be removed by nanofiltration process. The next question is match the following process with their characteristics. We are talking about different filtration process: electrodialysis, reverse osmosis, nanofiltration, and thermal distillation, and their characteristics. Please try to match these. Okay, we'll see the solution now. The solution is electrodialysis is the process which is electric voltage driven and not pressure driven. Of course, by the name electrodialysis, this is coming. Now, reverse osmosis is the movement of water from low salt concentration to high salt concentration by applying pressure. So, normally, what will happen? This is a semi permeable membrane. Normally, what will happen? Here, high salt is there. Here, low salt is there. So, water movement will be like this. Okay, movement of water. Okay, but when we apply pressure at one side, in this side, the movement of water will be reversed. Okay, so this is what we want. So this is osmosis from lower water, higher water concentration to lower water concentration means low salt concentration to high salt concentration with osmosis. But when we do reverse it is called reverse osmosis. Third is nanofiltration is operational challenges are scaling and falling. Yes, well, this is very small. So bacteria, algae, they may form some polymeric substance which will stick on it, and the further filtration process will be very difficult. In thermal distillation, yes, it uses heat. The work of the word thermal, it's well understood. It uses heat and convert water into water pressure. Okay, water vapor. So then this water vapor will be condensed and a good quality water will be obtained. Question number 8 is calculate the water recovery for the following reverse osmosis process: permeate flow, feed flow, and we have flux. So we need to calculate the water recovery, how much water will be recovered. Please try to answer this question. We'll see the solution in a while. Okay, we'll see the solution now. The recovery is just nothing but permeate flow divided by feed flow. So, what is in a RO process? We are giving feed. From the other side, permeate is coming out. And here, rejection is coming out. We also call it concentrate. So our aim is to maximize the permeate, means more amount of water we should get. Okay, so this is our target. So what is permeate then? Permeate divided by what is recovery, means how much water we want, is permeate divided by feed. So this is our answer. 85%. We are getting 85% of permeate and rest 15% is going in reject stream. Select the correct statement regarding reverse osmosis theory. Chemical scale fouling in membrane occur due to increased concentration of relevant ions in concentration. Solute rejection is lower for highly charged molecules but higher for larger molecules. Volumetric flux is given by this formula. Membrane material is susceptible to biological degradation and degrades its free chlorine concentration below 1 milligram per liter. Here we are talking about the type of membrane that we use for reverse osmosis. Please try to answer this question. Okay, we'll see the solution now. Solution is A and C. So volumetric flux of water is given by this formula. Yes, correct. And the chemical scale fouling in membrane occur due to increased concentration of relevant ion in concentration. Hmm. So solute rejection is lower for highly charged molecule but higher for larger molecules. So this is wrong. Okay, this is just opposite. And membrane material susceptible to biological degradation. So this is also wrong. Chlorine concentration can go below. The next question is select the ways in which both iron and manganese removal can be done. We are talking about iron and manganese. Okay, so these are present mostly in the groundwater. So for their removal, many various processes are there. So what can be the process for them? Please try to answer this question. I'll see the solution now. Chemical oxidation, lime soda ash softening, and sequestration. We can also do some aeration. Aeration, they will sit at the bottom. Okay, but the basic processes are chemical oxidation, lime soda ash softening, and sequestration. Okay, so that's all for today. See you guys next week.